All right. Welcome to 14.3, When All the Stars Align. Before we get going on this activity, I want to check in with you on lesson 14, activity 2. The very last expression, which you did in your discussion, was write each expression in standard form. So this was the last expression. I just wanted to make sure that we agreed on this binomial squared is equal to this trinomial, right? So I just want to write it out for you real quick. If we multiply kx plus m times kx plus m, you could do the area model. Some of you do that, or you could do distributive property. In this case, I'm going to do distributive property. So we've got k times k, so that's k squared. X times x is x squared. That's a little different than we've seen in the past. Kx times m is plus k times m times x, right? A k, an m, and an x. All right. Then we've got m times k times x, which really, these two things are the same thing. It's just a different order. And lastly, m times m. All right, so we can combine these two middle terms. We end up with, which color to use here, k squared x squared plus, we have 2 km's with an x next to them plus m squared, right? So if we just are looking at the coefficients of the x, we've got k squared, 2km, and m squared, right? So looking at what's in front of the x squared. So that was what you may have figured out in activity 2. So we're going to be using this. So I wanted to make sure we were ready for that. Okay. So activity 3 is when all the stars align. We need to find the value of c to make each expression in the left column a perfect square in standard form. Then we're going to write the equivalent expression in of the form of squared factors. In the last row, we're going to write our own. We'll see. We might not do that. But let's do this. So here we have our trinomial, right? It's got 3 terms, so we call it a trinomial in standard form. And then we want to rewrite it as a binomial squared. Okay. So here we've got the first 2 terms, but we don't have this last. So we need to do some investigation to figure it out. So here I see aligned k squared and 100. So I'm thinking, okay, well, 10 times 10 is 100. So I think k is probably 10. So right here I'm looking here. If my k squared is 100, then the k is probably 10. And that's my theory right now. Okay, so if k is 10, that's 10 squared. And then here, 2 times 10. Well, 2 times 10 gives me 20. But I have to multiply by some other number to get to 80. So 20 times what number gets me to 80? Well, 20 times 4. All right. So here what I'm seeing is maybe m. So here, k equals 10 and m equals 4. And we kind of reasoned through that, rationalized through that by what we knew and what we could figure out. So we had 2 times, k was 10, and we needed another 4 to get us to 80. 4 times 2 is 8, times 10 would be 80. All right, so if m is 4, then to get the c value, I need to take m and square it. So 4 squared is 16. So to complete this square, I would need that to be a 16. Okay, so here, m is 4, so I'm going to say plus 4. Now, this is definitely my first one. I want to double check, so I'm going to go ahead and multiply those out and make sure it works. 10x plus 4. 4 times 4 is 16, 100x squared. Here we get 40x, here we get 40x. They add up to give 80. So it looks like 100x squared plus 80x plus 16. So we're good. All right, there are 3 more for you to try. So I'd like you to hit pause and When you are done trying, hit play and we will go over the answers. All right, you should have tried these on your own. So here we found that k is 6. And then if that's 2 times 6, 2 times 6 is 12. Well, we need a 5 in there, right? 5 times 2 is 10, times 6 is 60. But it needs to be a negative number. So, okay, so we're going to need this to be a negative 5 to make that work out. So our k value, we decided, must be 6. And if k was 6, then our m value must be 5, but not just a 5, a negative 5. All right. And if I square that, I will get this perfect square. So this must be 25. Okay. All right. Here we got k equals 5. K equals 5 and m equals what? Let's break this down. This is 2 times 5 times m. 2 times 5 is 10. 10 times what? 10 times 4 is going to get me to 40, right? So m must be 4. All right. So hopefully you've already tried these, and I am just confirming what you already figured out. This last one, we've got a decimal, which makes it a little more exciting. All right. So here, 0.25, what times what is 0.25? Well, it's similar to 25 because 5 times 5 is 25, but we've got this decimal. So actually 0.5 times 0.5 would be 0.25. So k equals a half. A half times a half is a quarter. That's another way of thinking about it. All right, so that's our k, and we need to find what our m is. So if I have a half times 2, well, that cancels out. We just get 1. Well, 1 times what? 1 times 14. Looks like m is 14, but a negative 14. And then 14 squared is 196. All right, so our c value is 196. Here, what was our c value? 16. Here, 25. Here, 16. All right, so 14. So we've got 0.5x minus, how did I know it was minus? Because of that negative, minus 14 squared. All right, and the last couple questions are here. Sorry about that. The last couple questions are here. This is saying solve each equation by completing the square. All right, so we need to use this pattern that we've talked about, like, hey, I can rewrite this as something squared equals whatever. So I've got to figure out what c value can I add here to make this a perfect square. Let's add a line in there. So 25x squared plus 40x plus something equals negative 12. And I like to put kind of a space there just so I know I'm going to be adding something. So we said, okay, k squared, so I know it's going to be a 5x here. Okay, so this is k squared, right? This is 2 times k, which I already figured out. 2 times 5 is 10. 10 times 4, I still need a 4. So I've just figured out my m, right? 2km is equal to 40. So I could write that equation out, but I figured out that the other number I need is a 4. So my m is 4. All right, but if that means 4 is my m, to get that c value, I need to take that m value, that 4, and square it. 4 squared is 16. So I need to add 16 here and add 16 here on both sides. I can rewrite this trinomial as a binomial squared. That's what I did here. Those are the same amount. If I multiply these back together, I should get this, right? 5 times 4 is 20. 20 doubled is 40. 5 times 5 is 25. 4 times 4 is 16. All right. And then on this side, I get positive 4. Now I can square root both sides, plus or minus 2. Square root this side, and I get 5x plus 4. So we can separate that into two answers. 5x plus 4 equals positive 2, or 5x plus 4 equals negative 2. And subtract 4, and subtract 4 and divide by 5. All right, so our two solutions on this one for this would be x equals negative 2/5 and x equals negative 6/5. All right. I kind of walked you through that one, so I'm going to let you have more freedom on the second one. So go ahead and hit pause, work through your steps. If you want, you can move the 10 out of the way, or you can add to 10 to get the number that you need. All right, go ahead and hit pause. When you hit play, we'll go over it. All right, you should have already tried this one. So here I've got k equals 6. 6 times 2, and I need a 5. So m equals 5. So if I know k is 6, I'm going 2 times k times m equals negative 60, right? This 2 times k times m has to equal negative 60. So if I already know 2, I already know k is 6. 2 times 6 is 12. 12 times what is 60? Well, it has to be actually a negative 5, right? So we've got to figure out what is that leftover number that we need. It's a negative 5. Okay. So if I take negative 5 and I square it, negative 5 squared is positive 25. So here, I need this number to be positive 25. It's not yet, so I need to add 15 more. When I do that, now I have 25. So 36x squared minus 60x plus 25 is now a perfect square. And that equals, let's see, 9. Yep. I can rewrite this as a binomial squared. 6x minus 5 squared. All right. And if you want, you can check it. All right. So now remember, something squared equals 9. Well, it's either a positive 3 or it's a negative 3. Oops. We don't need to write it twice. We can just say plus or minus 3. Plus or minus 3. So 6x minus 5 is equal to a positive or a negative 3. All right, then we write it out 2 times. All right, add 5 to both sides. Add 5. Divide by 6. 8/6, that can simplify, and 2/6 can simplify as well. So what do we get? 4/3. If you want to write it as a decimal, I'd say a fraction is better. This was supposed to say 2/6. Okay, so that becomes 1/3. I prefer fraction to decimal in this case because the fraction is more exact. A decimal you would need to approximate. Okay, so those would be our two solutions. Great, thanks for watching. This was an optional video. Okay, this will not be on the quiz. Thanks for watching.